Okay, here we go. Real quick lesson on current. So, as the diagram shows, it's a obviously much larger than typical wire, and it's showing these kind of little cartoon balls representing charge. So, current in and of itself is just the flow of charge. Now, specifically, and this is going to be on the next page, electrons. So even though they're saying Q for charge in general, we know that electrons are the ones that move. We talked about that earlier in the chapter. Now, more specifically than this, current is the rate of change of charge flowing through a wire. It's how quickly charge moves through a specific point. So it's kind of nice to have this here. Let me erase this. Oh, erase a little bit of this. Kind of see how they have this little cross-sectional area. It would be basically the amount of charge goes through any one kind of cross-section of a wire at any one time. So this is our formula. Now, it's weird, kind of, that they use the letter I, and there's a historical reason for it. It comes from something known as impedance, which we're not going to really talk about. But just know that I represents current, Q represents charge, so it says delta Q, so it's change in charge. It's the total amount of charge that goes by in that amount of time. So time is seconds. So this is going to be in coulombs. Oh. This is going to be in seconds. So then current is technically then coulombs per second, or amperes. So let's go to the next page. Some concept notes. In order for a current to flow, there must be a potential difference. So there must be a voltage. There must be some reason for electrons to want to go from one location to another. If there's no potential difference, just like if I have a mass and it's sitting on the floor, there's no potential, there's nowhere for it to want to fall. I'd have to pick that mass up and let it drop. So there has to be some sort of a potential in order for that particle, that electron, or that mass, however you want to look at it, to move. Okay? I had mentioned this on the last page. Current is always a flow of electrons. Electrons, electrons, electrons. Okay? And it says here an ampere is a large current. So there will often be prefixes attached to the current. For instance, example, milli. They love milli. So milliamps would be 5 times 10 to the negative 3 amps. Okay? If you had 5 amps of current, that's a tremendous amount of current. That's about a quarter of all the current your entire house can handle. So that is a tremendous, tremendous amount of current. Okay? So more often than not with current, they're going to use these prefixes. Okay. Now, real quick, we'll do 2 examples, and then we should be good to go. So 4 microcoulombs of charge flow through a point in a wire in 20 seconds. What is the current? So we're going to say I equals delta Q over T. So I is going to be delta Q. So it's 4 micro. So 4 times 10 to the negative 6 coulombs divided by 20 seconds. Okay, so I will give you a second or two to work out that math.